Hey, how are you? Can you hear me?
Yeah, great to have you here, Aaron. Yeah, like welcome to the workshop. Thanks for joining us today. And yeah, feel free to introduce your topic any moment from now. Thank you. This is Steve from DoraHacks, by the way. Yeah, very glad to host you here.
Yeah, great. Thank you for having us. Yeah, so I'll just go ahead and get into my slides here. My name is Aaron Sutula. I'm an engineer at Textile. You're going to learn more about the projects we work on at Textile today. And really, I just want to show you how we try to make it easier for anyone to store data in IPFS and Filecoin using our libraries and our APIs. Before we get into the details there, I just want to mention if you like what you see in this presentation and you think Textile is an interesting company and you're looking for a job, we are hiring right now, and hopefully we'll be hiring more throughout the rest of the year. So visit our website to check that out if you're interested. Okay, so just a high-level overview of the projects that Textile builds. They're all focused on making it easier to develop on IPFS and Filecoin. First one is called Threads. It's a data synchronization protocol and database API over libp2p. Another one is called Buckets, which is like a folder and file storage API and library built on IPFS and Filecoin. Another project called Powergate, which is an IPFS and Filecoin data storage kind of pipeline orchestrator platform. And then a hosted service we call Hub that kind of ties all those other services together that you can use to kind of just like plug and play sort of use of these Web3 technologies without having to host anything yourself. So that's the overview. We're going to get into the details, into more details of each one of those in the rest of the presentation here. Okay, so start off, let's talk about Threads. Like I mentioned, Threads is a data synchronization protocol. Synchronizes data using events written to IPFS. And those events are pushed and pulled to different local Threads nodes in the network using libp2p. There are a few different components to the system. One is the Threads daemon. So this is a Go project. It's a daemon that runs a node on the network, and these nodes communicate with each other. The Go Threads is a Go client implementation that's able to connect to any Threads daemon to read data, and JS Threads is the JavaScript implementation of that Threads client. As well as we also have a pure JavaScript node that can run locally as well and participate into in the network. So just some Threads concepts. Most applications will interact with Threads data using a database API provided by the client. The API looks a lot like what you might be used to if you use something like MongoDB. Each thread database is known by a unique thread ID, and that ID is unique on the entire network. It can be used to connect to a database or a thread, or invite others to participate in that database or a thread. Each database contains many collections. Each collection has its own schema and set of validators that you can specify for the data. And each collection, of course, has many records of a particular type that match the schema. So these are concepts you're familiar with in other database type of systems. A little more detail on Go threads. Like I mentioned, there's the daemon you can use to run the threads node, the client, and here's some little code snippet on the right, just showing an example of creating a thread schema using like a Go struct, a person. So we're creating a JSON schema from that person and then creating a collection inside of a database that we can then write to. Little more detail on the JavaScript threads library. We have our client that connects to the full thread node, but also, and this is a really cool feature, is our local first JavaScript threads implementation, which actually will run a threads database kind of in a local first or offline first mode inside of a web browser or Node.js application. And here's a code snippet on the right showing the creation of a database using a JSON schema from JavaScript here. And then we create a reference to a new collection called person, insert a person named Carson with an age of 37. And then we use the Mongo-like API here to save that entity in the database, and then you can check that it exists and then do searches later on to find previously stored data. We have a lot of ideas about where threads might go in the future. We're really focused on using threads as a data synchronization protocol over libp2p. So this opens up a lot of new ideas, using P2P services to replace REST servers with an open network of APIs, really enables a lot of interoperability between standards like DID and IPLD and even more. If this is interesting to you, go on over to our GitHub page. We have a discussion going on there about the future of threads and these ideas about how to integrate into other interoperable systems and data synchronization methods. Okay, next we're going to talk about buckets a little more. Now, buckets provide folder and file storage, synchronization, and sharing on IPFS and Filecoin. And it's a very familiar and easy to use API, but very powerful at the same time. You can interact with buckets using a command line interface or using a library, an API through a library to embed buckets functionality inside of your own application. Buckets can be single user or multi-user. You can invite other users to collaborate on bucket content. Buckets are multi-protocol. They bridge multiple protocols together to support a lot of different use cases. Buckets are built on top of IPFS. So anytime you write data to a bucket, those changes are stored in IPFS, and the root CID of your bucket changes every time you modify the tree, the hierarchy of the folder files and folders stored within the bucket. Every single file inside of a bucket, of course, has an IPFS CID associated with it. They support IPNS, so despite the CIDs changing every time the bucket contents changes, the bucket provides an IPNS address that is a stable address over time for that bucket. Buckets can be viewed over HTTP at a static URL, and buckets can be archived to Filecoin. And this provides kind of like an archive snapshot functionality for a bucket, and we'll get into that a little more here soon. We have a JavaScript library for buckets. This lets you use the Buckets API programmatically within your JavaScript application. This is powerful because you as a developer can incorporate Buckets functionality, to support your application using account keys. So these are like your developer account keys. Or you can actually create user keys. These are keys that represent the users of your application. And you can actually, for example, create a bucket. Each user of the app can own their own bucket, or users of your app could collaborate with each other on bucket contents, things like this. Go Buckets is our Go client, or a Go library for buckets. This is kind of some new work where we just split it out into its own repo. It's a new repo that makes Go Buckets completely standalone. You can run the Go Buckets service yourself if you want to. And then you can, of course, use the Go Buckets client to communicate with that service, or that daemon. And then you can do really powerful things with this library, like build desktop applications, tray utilities, background services that efficiently move data across IPFS and Filecoin using Buckets. And Buckets also provides effectively an IPFS pinning service through the Buckets API. And you can get that up and running really easy using Go Buckets. Now, a really interesting and powerful feature of Buckets is that it's actually built on top of what we previously talked about, the Threads technology. And you can combine those two technologies to make them even more powerful. So if you think about how this might have been, this is implemented, using Threads, we basically defined a Buckets schema, a data model, registered that within a thread database collection. And so every time a bucket is created or updated, it's really updating the underlying Threads database data model or database. And what's great about that is you can use all the underlying Thread APIs and technologies to do some powerful things, like mapping events, data change events at the thread level to like other Threads database schemas or events. Every bucket file has its own CID that you could reference inside of another Threads database data model. So kind of linking together your database object model with files stored within like the folder and file structure of a bucket. And you can use bucket archives to store all your bucket data on Filecoin. So getting a little closer and closer here to more Filecoin integration. Next, we'll talk about our Powergate project. Powergate is a production-ready IPFS Filecoin stack. It integrates IPFS in Filecoin in a way you can think of as like a hot and cold storage layer, kind of caching, where you think of like hot storage as your kind of readily available hot cache layer, and Filecoin is cold storage, kind of long-term archival data, and Powergate coordinates the storage between those two layers quite nicely. It can handle 1 to thousands of Filecoin wallets and manage scalable dual storage pipelines. And it also provides a IPFS pinning API for any data that's stored in the IPFS or hot storage layer. This will all make a little more sense when we get into the details here. So to understand a lot about how Powergate works and how it stores data, we can look at what's called a storage configuration. Powergate works based on, it's kind of like a declarative configuration mechanism for storing data. Your data exists on IPFS, or you can import it into Powergate's IPFS node, and then you declare the configuration you want that data to be stored with, and you apply that configuration to the IPFS CID, and Powergate does all the magic behind the scenes to make sure that the storage state for that CID matches what you specify in your storage configuration. So let's look at one of these storage configurations to learn about how Powergate stores data. So here we're looking at a default configuration. If you just start up Powergate from scratch, this is like the default way it will just store data if you don't specify otherwise. You can see the configuration is split into hot and cold. And the hot part of the configuration maps to IPFS storage. The cold part of the configuration maps to Filecoin storage. Like I mentioned earlier, we can consider the hot storage kind of like the readily available, fast access storage, and cold storage to be the long-term archival kind of version of the storage. So if you enable hot storage, there's a couple options you can set. Allow unfreeze is a really interesting one. This means that when you want to store the data in IPFS, are you willing to actually do a Filecoin retrieval deal to get that data from Filecoin if it's stored in Filecoin in order to populate the hot storage? You can specify the maximum amount of fill you're willing to spend in order to do that retrieval deal. 0 means no maximum. Within the cold storage, I'm not going to go through every option here, just the interesting ones. So let's just jump to cold storage here. If you enable cold storage, your data will be stored in Filecoin. And here we specify a lot of Filecoin specific types of attributes here. Replication factor is a very interesting and powerful one. This is something that Powergate adds. This doesn't exist in Filecoin directly. So the idea is if you want to store your data with many different miners to have some amount of replication, you can specify that here, any number you want. You can specify the amount of time in Filecoin epochs you want your deal to last. Excluded miners and trusted miners. This is really useful if you want to specify miners that you don't want, that you know you don't want to store your data with, or miners that you would prefer to store your data with. So in the case of trusted miners, if I provide some miner addresses here, Powergate will do everything it can to try to make the storage deals with that list of miners before choosing miners otherwise. Country codes is also really useful Powergate feature. If you want to target specific geographic areas, you can specify a list of countries you want to try to store your data in. And then Powergate also supports auto renewing of deals. So Powergate will actually monitor stored data for deals for when they're going to expire and actually create a new deal before the previous expiration if you have renewal enabled here. A couple other things. Max price is just kind of a safety setting. You can just set a max price you're willing to spend to store your data. That's like in units of autofill per gigabyte per epoch. A 0 here just means no limit. We can specify that the miner stores data with fast retrieval enabled, like a deal start offset. And importantly, Powergate does support verified deals as well. So if you have a verified Filecoin address, you can use it to store data using Powergate and get cheap or free storage that way. Powergate also supports repairing storage. So if you set repairable to true, it will monitor the health of your stored data. And if it detects that, for example, a miner is no longer storing your data when it should be, it will repair that storage and try to create a new deal to replace that failed one from before. Powergate comes with a couple really useful Docker tools, Docker Compose configurations, basically. One is called LocalNet. It's really useful for the development stage of your product. You can run LocalNet on your computer, and it will run a fully featured Filecoin network right on your local computer. It runs that local blockchain at a really high rate, so things happen really fast, and you can kind of develop your app quickly, use all the Powergate and Lotus APIs that you want, and get really fast feedback and develop your application without having to worry about running on a Filecoin mainnet or even one of the test nets and dealing with those slower speeds and things like that. And then when you're ready to push your app to production, Powergate also provides a Docker setup to run in production if you want to run your own like Lotus node and Powergate node on Filecoin mainnet. Okay, now on to our hosted service called Textile Hub. Now, I just want to make it really clear, all the technologies we've talked about so far are all available open source and standalone. Anybody is free to run any of those technologies and use them within their applications, host them, whatever you want to do. But if you want an easy solution just to sign up for an account and use all of these technologies in your app without having to worry about hosting them, we offer Textile Hub. Hosted access to IPFS and Filecoin networks, APIs for bucket persistence, threads, thread databases, Powergate, and more. Sign up is free. You get instant access to IPFS and pinning for your buckets and easy to use client libraries that we talked about earlier. Those all work with Hub. We provide hosted Powergate instances if that's something you're interested in, and simple Filecoin APIs for your data. Here's just kind of a list of the different tools and APIs available through Hub. All things we've talked about earlier. And as a developer, you can use Hub in a couple of different ways. Once you sign up, you can use it strictly for kind of developer team collaboration. Buckets are really useful for this. You can collaborate on files and application assets or things like that using a bucket. Invite your team members to collaborate on that bucket with you, kind of in the way that you would use Git. But you also have the ability to push that data to Filecoin anytime you want. And then on the other end of the developer spectrum here is app building. So you could use Hub and all of the libraries to actually embed into your application and use our user keys and account keys to let your application users interact with Hub and the IPFS and Filecoin technology supported there. Now, this is probably the easiest way to store data on Filecoin through Hub, and this is using bucket archiving. This is something I mentioned a little bit earlier in the presentation, but we'll just give a little example of it here right now. So if you were to create a Hub account using Hub init, this is basically just signing you up for a Hub account, logging you in. You'd then be in a position where you could create a bucket and push data to it. In this example, we're initializing a new bucket, and we're using a special flag, --CID, which is basically telling the hub to create a new bucket initialized with an existing IPFS CID. Now, if you wanted, you could just create the bucket and then add files to it, files and folders, any data you wanted, and you could use a command called hub-buck-push to push that data back to the hub, and be in the same situation as we are here, just a bucket that exists on the hub with some data in it. Now, in order just to see some of the integration between hub buckets and Filecoin, we could run a command here, hub fill adders, and this would print out our Filecoin address associated with our hub account. Next, as we prepare to store our bucket contents on Filecoin, we could modify some things about our storage configuration. The storage configuration is similar to the Powergate storage configuration we were looking at earlier. So we're updating our default storage config, enabling fast retrieval, and in this case, setting a list of trusted miners and a replication of 2. And optionally, we could specify that we want to use our verified, if our address, our Filecoin address is verified, we want to use that to make a verified deal. And at that point, it's as easy as just calling hub-buck-archive. And that kicks off the process of actually archiving your bucket data onto Filecoin. And there's additional commands that you can use to check on and receive updates about the status of that Filecoin storage deals, the Filecoin storage deals happening over time. One thing mentioned here is the miner index. You might wonder how to specify things like trusted miners and rep factor, and how do you know like what type of details you might want to specify there. So this is a really cool feature of the hub. Basically, since we're running a lot of Lotus nodes and Powergate instances in the hub and making lots of deals, we're able to index a lot of metadata about those deals. And we make all of that metadata available to any hub user using the Miner Index API. It allows you to query miner statistics, profiles, use the deal calculator to get estimates as far as like how much it might cost you to store a certain amount of data on Filecoin for a certain amount of time. Provides a REST-based API and Swagger, kind of like open API web interface that you can use to explore the Miner Index APIs. So you can get started with Hub by visiting our website and documentation, and pretty easy to get signed up from there. The last thing I want to mention is just kind of where we're going with all of this IPFS and Filecoin technology and knowledge that we've learned over the past years building all these tools I've already talked about. This was mentioned in the last presentation a little bit, but the idea of creating bridges between different sources of data and Filecoin. And so we're focused on different blockchain developer communities and providing an easy to use bridge API to allow people to store data from within like their own blockchain native environment, developing their app there to easily store data on Filecoin. We're kind of making a proof of concept of this first using the Near network, making really good progress on that. You can go to near.storage to learn more about the specifics of how this all works. But we'll be announcing more as this develops and we move to other blockchain networks as well. Just a little teaser example here. You can see this web application authenticating to a Near account using the Near SDKs. We're logged in now. We're going to have this user lock funds with our bridge smart contract. Locking funds is just a way for us to kind of prevent Sybil attacks. It's kind of staking funds that will be returned to the user. Now the user is choosing a file they want to store in Filecoin, and they're uploading it to the bridge or the Oracle. You could think of it as that. So that data is being processed now by the bridge Oracle. And we can check the status of that data as it is being processed and prepared for storage on Filecoin. And eventually that data would be actually put into a storage deal that is stored with a handful of miners on the Filecoin network. Simultaneously, the data is available on the IPFS network to use within the application. So that is all I have for today. So thank you so much for letting me present here. I know I covered a lot, so be sure if any of this is interesting to you to visit our website, check out the documentation, and we have a great community over on our public Slack channel, so you can go there and join and get in on the conversation, ask any questions that you have. Yeah, thank you.
Yeah, thank you so much, Aaron, for joining us today. Yeah, I'll make sure all the audience, like all the Chinese developers, have any question about Powergate, Textile, I'll make sure they'll join the Textile Slack channel after like this workshop. Yeah, thank you so much.
Sure. Just to answer this one question,
sure, please.
Does Textile automatically have data cap for verified deals? So it would be up to the hub owner of like any hub account to get their address verified and get data cap for their own address. We don't provide that data cap. So that's it.
Yeah. Thank you so much for your time. So you're based in Mexico, Aaron?
I am, yeah, I'm in Mexico City.
Nice. So Textile is a very diverse, like you guys are based everywhere, right?
Yeah, we're spread out all over.
Awesome. Yeah, if you can, please also share the deck with us that you share with the audience today.
Okay.
Also, like we can help promote with your job openings to the developer community globally. Yeah.
Wonderful. Thank you so much. I will share the slides.
Yeah. Okay. I'll turn to the Chinese audience now.
All right. Thank you
so much for joining us.
Bye.
对，感谢大家参加我们今天的Filecoin workshop。今天我们给大家带来2场分享，分别是ZX 为大家带来的 Web3 新玩法，Filecoin 生态上的无限商机。ZX 分享了在 Filecoin 上面可以创业的方向，并且分享了大家作为开发者可以去延展的一些子领域，包括可能在 Filecoin 上面的像 Data Bounty， 还有这个 NFT 等等不同方向上的一些可以去探索的方向。大家可以去我们会在后面收集到今天分享的 deck， 今天分享 PPT， 并且分享给大家，大家这个可以再去学习一下。然后第二个呢是由Textile 的 lead 这个首席工程师 Aaron Sutula 为大家带来的这个 Powergate 和 Textile 的新功能的这个介绍。大家可以在后面多关注 Powergate 和 Textile 能够给大家带来的这个在开发上面的一些便利，并且这个他们能够提供什么样的支持。我们和 Filecoin 就是 DoraHacks 和 Filecoin 一起去举办的 Filecoin Grant 1，Filecoin Grant 1，现在还在HackerLink 上面这个进行，我们已经有10多个项目申请了这个 Grant，但是我们还在持续的录取，欢迎大家我们是对所有开发者开放的，所以欢迎大家来这个申请我们的这个 Grant， 为自己的这个项目获得启动资金和来自 DoraHacks 和 Filecoin 官方提供的在宣传上、资源上的各种支持。这个 grant 会一直持续到7月18号。所以如果你有任何关于 Filecoin 学习上、开发上还有资源上的问题，欢迎你来联系脑洞猫，或者是 Filecoin 官方加入 Filecoin 的开发者 Slack 群，还有像今天Aaron 提到的这个这个 Textile 的这个 Slack 官方群，或者你可以联系 DoraHacks， 我们会帮助你加入到这些群里面。大家可以持续关注DoraHacks 和 Filecoin 的更多的活动。我们接下来会跟 Filecoin 持续的去组织更多的 workshop， 并且邀请 Filecoin 生态项目来 DoraHacks 做直播。所以欢迎大家来这个持续关注。我们还和其他的生态有一些更多的开发者方面的合作。明天是我们的 Hackle Grant 1的正式的截止。还有我们和 Solana 还有其他的这个活动。大家如果对 Filecoin 的生态开发感兴趣，欢迎大家 stay tuned 更多的 Filecoin 的这个直播。如果大家对其他的开发活动感兴趣，欢迎大家联系 DoraHacks， 我们会给大家这个提供最好的行业资源，帮助大家加入到不同生态的建设当中去。好，那今天就不更多去占大家的时间。今天在北京时间很晚了。如果你有任何问题，欢迎联系我们。今天的直播就先到这里，感谢大家的时间，大家晚安。